So complete the truth table for the logic system P equals not A or B. Sometimes it does help if you just spend a little bit of time creating the logic diagram for a scenario, for an expression. So let's start off there. What would be the first gate we would put here? We'd go for an OR gate, again, because it's in those brackets. So I'll start off by drawing an OR gate. Label that as OR. What would my two inputs be for this OR gate? A or B. So there's A. And there is B. And then this is directly going into a NOT gate. That is my NOT gate. And that would output what P is. So, that is a logic diagram for this scenario here, this expression here. What we have to do is complete the truth table. So, if A is 0 and B is 0, so let's say A here is 0, B is 0. In an OR gate, what would that output? Robert, in an OR gate, what would input 1 and input B output in an OR gate? They were both 0, both false. 0. So at this point, we're currently outputting a 0 here, but then it gets passed through our NOT gate. Our NOT gate will then do what to the 0? Turn it into a 1, which is why we've currently got P as a 1. That makes sense? So now we're going to go again. This time A is a 0, B is a 1. What would that output as? That would be a 1, wouldn't it? Because only one of the statements need to be true. So there's a 1 here. We pass that through the NOT gate. What does that 1 now turn into? 0. So there is our first answer. We're going to do the same. This time A is a 0, B is a 0, outputting a 1. We put it through the NOT gate. That will also output a 0. We're missing the two inputs here, but we know they're going to be 1 and 1. If A is 1 and B is 1, we pass it through the OR gate. Output would be a 1. We pass it through the NOT gate. 1 now becomes... And that's it. There you have it. So now you've got the truth table for this expression and also the diagram for this expression. If it helps, complete this, draw the diagram. It does help.